Hey everyone, so today we have an algorithm challenge. We have a problem called Decompress. I'm just going to go over it really quickly in terms of reading it and kind of explaining what the example is and try to see if you can solve this on your own. And if not, I'm going to be going over my solution basically and helping you through it. They want us to write an algorithm that takes in a string that contains numbers and letters and return basically a string where the number before any letters is the number of times that letter should appear in the string. So for example, we have decompress 5p 10a 4z as a string. And what's happening is that it's saying, all right, there's 5p, so we're going to print that 5 times. There's 10 a's, so we're going to make it 10 a's. And there's 4z, so we're going to print out, as you guessed it, 4 z's. So you can pause the video here if you want to give that a shot. But anyways, we're going to be going into a solution now. So let me outline how I would approach this problem. All right, cool. So let's jump into this example here, 5p10 a4z. So we're creating sort of a parser, if you will, where we are going through each of the parts of this string, each of the indices of this string, and kind of splitting this up. So each of these letters and or numbers, think of them as, just 0, 1, 2, 3, 4, 5, and 6. Sorry for my atrocious handwriting here. And so we're looking to say, all right, the first indice of 0, we are checking to see if this is a number, right? And if it is a number, that's great, but we're really looking ahead to see what's ahead of it. In this case, we have the letter P. P is important, or our letters are important because we need to basically copy that letter X amount of times, X being the number before it. So we need to kind of make sure we also keep a way to keep an eye on 5. Because without 5, we don't have any instructions for P on how many times it should repeat itself. Then we also have a different challenge, because we have a challenge where to humans, this looks like the number 10, right? But when we're parsing through each of these indices one by one, this isn't really 10 at this point. This is just like 1, and then it's 0. So we have to keep track of multiple larger numbers. We have to look at this number 1 and then look at the next thing and say, okay, this is a 0. So we have to keep track that this is the number 10, not just the number 1. And then when we get to A, we look back and say, okay, A needs to be repeated 10 times. So that presents a new challenge in itself. So let me undo all this and explain my approach to kind of keep track of everything and how I would move forward in this problem. So the first thing is, and just to make this easier, I'm going to create 2 different colors here. I'm going to have I, which is equal to 0 as green. So we'll make that a little bit larger. And then we're going to have, we're going to make a J. And I'm going to make the J, what is this, red here? So I'll make this J equal to 0 too. And of course, we need to basically have it's looking to return a string, right? So we're basically going to say, I'm going to set the result to an array because I want to push something to it, and then we'll flatten it or join it later so that way it becomes a string. So we'll kind of output the result into an array and then make that flat. And again, I'm going to fully code this. I'm just trying to walk through like my thought process for approaching this problem step by step. So let's take this example again. So what my thought process is if we see that 5, we're basically going to try to create a gap between 5 and P, but we need to keep tabs on where 5 is, right? So we have this line which represents J as red, and we have this green line which represents I as green. So in this first instance here, we're going to say we're looking at the first element of this string. So by the way, I'm just going to call this, we'll just call it string to represent like what's being passed in. So basically 5p10 a4z is going to be string. That's whatever's passed into the function, right? And so we're looking to see string at the indice of j, which is 0. We're checking to see, is that a number? If it is a number, then basically all we're going to do is simply increment j. So j plus plus. The point of this is that if you make j larger, we're going to push j ahead here. And now we have something keeping track of 5. I is saying, hey, I'm at index 0. I see the number 5. but j is saying, I now see a letter, so hey, I need to call on you. So what's going to happen is j gets larger, right? And so the next time around on this loop, now let me write these numbers out again. So we have I and j. So I'm going to bring this down here. J is now equal to 1 because we incremented it right here. We checked if string of 0 is equal to a number. It is, so j plus plus, right? So now j is equal to 1. Now we're checking, is s string of j a number? Is string of 1 a number? So 0, 1, p is not a number. So we have to do something else. And what we're going to do is we're going to slice it. So what we're going to do is we're going to take this string and we're going to actually slice it at, and in this case, it's going to be ij. And the reason why it's ij is because the way slice works is we're basically, if I change this to 0 and 1, we're checking between, basically, we're starting at the 0th index and going up to the first index. So we're starting at 5 and going up to 1, but we're not including p, we're only grabbing 5. So string sliced at 0, 1 is basically equal to 5. So what we can do there is basically set this equal to a variable. So we'll say, like, for example, let num equal string at slice 0, 1. And this is basically equal to 5. So now we have a placeholder that says, okay, now we have this number 5. So with this number 5, what we're going to do is we are going to multiply p by that number. And we'll go into, there's a method we're going to use called repeat, just to make it nicer. But what we're basically going to do is say that we want to take string at j, because again, string of j, which is string of basically 1, is p. So p, and we're going to repeat it num times, okay? And we're going to push that basically to the result array. And again, I'm going to go over that when I actually start coding it. So now, okay, we have this push to our result array. So now basically our result array will basically contain something where it's like p 5 times, right? So it's going to be p, which is cool, but we need to keep on moving. So I is at 0, j is at 1 at this point. We need to move ahead. So what we're going to do is we're actually going to increment j plus plus. Now j is equal to 2. So j is basically going to move over to here at this point. But you see we have an issue now because at 2, now we have I still at 0. I is kind of left behind. And what's happening is now it's looking at 5 and p if we were doing our slice. Like, for example, if we did slice of 0, 2, we would grab 5 and p. We no longer want to work with 5 and p. 5 and p are the past. That's the history. So we don't need that anymore. So what we're going to do is we're actually going to set I equal to j. So we'll do I equal j. And what that will do is now it'll move I up to j. And now I is caught up at 1, which is great because we can start over at this point. So now if I move this down here, what we're going to do is if we keep on moving here, now I is equal to j, which is 2. And as you talked about before, we incremented it, right? So j is 2. So I2, j2. So we're starting now at this point, which is 1. So again, we're checking, hey, string of j, which is string of 2. Are you a number? 0, 1, 2. 1 is a number. So what do we do when we see a number? We increment j. So now, if I grab this again, and let me just, I need to scroll down a little bit because I'm running out of space here. Okay. And actually, let me grab this because this is a useful visualization for you and me. Let me grab this down here. Okay. Okay, I'll move this here because it keeps on getting in the way of the line. Okay, so in this previous step, we just said, okay, string of j, which is string of 2, is a number because it's 1, right? So we're going to increment j. So now j is equal to 3. Now, is string of 3 a number? So is string of 3 is 0, 1, 2, 3, is 0. Is 0 a number? Yes, 0 is a number. So again, what do we do when we say a number? We increment j. So let's do this one more time. Now j is equal to 4, and I is still at 2. So again, since I is 2, j is 4, we're going to move j ahead to the 4th position. And so at this point, what's going to happen is we're going to say, is string of j a number? Is string of 4 a number? A is not a number, so we're not going to increment j anymore. Instead, we're going to do basically this section again. And of course, we're going to change the values here. So we're going to slice it. We're going to slice string at ij. And what that means is that we're going to do, instead of 0, 1, we're going to do 2, 4, because I is 2, j is 4. And 2, 4, if we slice at 2, 4, we're going to start at the second indice, and we're going up 2, but not including the fourth one. So that's 1, 0. What do we have? We have 10. So now num is equal to 10, which is great. Again, we're going to do string at j, which is string of a, the letter a. A, we're going to repeat it num times. Num is 10. We're going to repeat a 10 times. And then we're going to, of course, push that to the array. And then on top of that, what we're going to do is we are going to increment j and then set I equal to j. So in this case, j++ would be j at 5, and then I is equal to j. So now it brings it up. So you kind of see the pattern, right, where basically it keeps on catching I up whenever we are able to push something. So that way everything that was before it in the past is really no longer valid. It's no longer used, which is great because we don't need that anymore. It's already been utilized for our functionality. So hopefully this approach makes a little bit more sense. And now we'll kind of go into the code behind it, and we'll console log everything out to make sure that it works properly. All right, so let's start this up. Of course, we're going to do this in JavaScript. Again, I'm using Quokka, so if you hit Command-Shift-P on your Mac, you can go to Start Quokka on Current File, and that will basically just allow us to do things like, show console log. So like console log, for example, hi, you'll see it in blue. So let's just start with the basics. We're going to, and let me make this a little bit larger so you can see it better. So we're going to create a function just called Decompress. It takes in, of course, a string, like I mentioned before. Okay, so the first thing we're going to do, as I mentioned before, is we're going to declare what needs to be returned, which is just let result. And we're going to set that equals to an empty array. As I mentioned before, we're going to do let I equal 0 and let j equal 0, because that's where we're going to be starting off. And okay, so the initial declarations are kind of done. Now let's think about this loop, for example. So we have a string that we're going to pass in, and strings, of course, have a length. We're parsing through it, so we can do a while loop or a for loop of some sort to iterate through it. I'm going to do a while loop. So I'm going to say while j is less than the string.length. Let's do a couple things. So what was the first scenario we were checking? We were seeing if it was a number, right? So what we're going to do is say, we're going to use a handy function here that's going to be called isNan. And so what happens is that whatever you pass into here, if it's not a number, it will return true. But we're checking to see if it is a number. So instead we want the opposite of that. So we'll use the bang operator to do the opposite of that. So we're checking a string at the index of j. And remember, if we do have something at the index of j, all we want to do is just do j++. That's it. Now, if it's not a number, like let's say it's like the letter P, for example, what we're going to do is an else statement. And in this else statement, remember, we're declaring that num to keep track of where everything is. So we're going to say let num equal, and we're slicing that string. So we're going to do string.slice, and we're going to slice it at I and j, right? So in that example I showed you, remember that number in the first time around was 5, right? So it was what, 5p or something? So it grabbed that number 5 and it sorted as num. So that's the same thing that's happening here. And now that we have that number, all we have to do is take result, and we're going to push. And what we're going to do is we're going to push it using the repeat method. So what we're going to do is we're pushing s of j, and we're doing s of j dot repeat, and we're repeating it num times. And then after that, as I mentioned before, we're going to increment j, and then we're going to catch I up to j. After all of that is done, so let's go ahead and exit the while loop. After all of that is done, we are then going to say we want to return the result. But of course, we want to do something with that, because let me show you what I mean. So if I were to run decompress, and let's throw in 5a, 10, was it t? I don't remember what I even put there. And then 4z. Let's see what happens if I console log this. Oh, I put s instead of string, that's why. Okay, so if I console log this, I'm getting 5a's, 10t's, and 4z's. That's cool. But we have them as strings inside of an array as different elements. So instead, what we have to do is something called join. And when we join it, we can actually join them with nothing in between them. Like you could do, for example, like join it with like a comma, for example, and that'll basically take them out of the array and put them together with whatever you want to join between them. So you could put, for example, like I'm a joiner, and it will put that between every single, element that was in the array. But we don't want anything. We want to return a string that's basically just one flat giant string, which is what I showed you before. So that's how you return it. So hopefully you like this little algorithm. I'm hoping to create more videos like this. So if you did like this video, please do drop a like, a comment, and subscribe. It really helps my channel. And I'll be going into more algorithms in the future and breaking them down to this level of depth so that way you really understand what's happening. If you have any questions or even more efficient ways to do this, please drop a comment down below. I am by no means like the best solver of these problems. So if you find a better way to do it, please let me know. I would love to discuss pros and cons of different approaches. Thanks for watching, and I will see you in my next video.